So I set you a few questions on multiple term derivatives in the previous video. What I'm going to do here is I'm going to work through these with you, show you the solutions, how you get these, and then you can check your answers with that. Quick refresher for you though. These are the three questions that I set. So the first one was f of x equals 6x to the 4 plus cube root of x minus 3. Second one was y equals 2x plus 1 times x minus 3 in brackets on their own. And the third one was f of x equals x cubed minus 2 all over x squared. So let's have a ping at these. So first one, f of x equals 6x to the 4 plus cube root of x minus 3. Now, remember what we said originally in our video. We want these written as single terms, all on their own, all of the form x to the n, or ax to the n if it's got a coefficient. It always has to be written at that form at this stage. Once it is, we can then take the derivatives. So this first one, perfect. This one here, the minus 3, that's perfectly fine. The cube root of x we have to change. So we have to rewrite this as f of x equals 6x to the 4 plus, now cube root of x we have to write in the form x to the power of a third, and then take away 3. Once we've got it written like this, then we can take our derivative. Then we can just do it term by term. So we can say fine, so f dashed of x equals, and remember the stages. Write the coefficient if it's got one, then do a derivative form for that. So we do 6 times, and then derivative of this, remember, power down, reduce the power by 1. So 6 times 4x cubed, plus, no coefficient here, so we just do that. So 1/3, bring the power down, and then 1/3 take away 1, gives me negative 2 over 3. And then we take the derivative of a constant, but remember the derivative of any constant in the world is always 0. So we've got this, we're left with these two single terms here. And then it's a case of simplifying them as much as you can. So first one, 6 4s are 24, so I get 24x cubed plus 1/3 x to the negative 2 over 3. Now remember, this sort of one here, x to the negative 2 over 3, can be written in a slightly different form. Some questions will say to you, write all your answers with positive indices, and in that case, you'd have to modify this. Remember, anything x to the negative n is equal to 1 over x to n, so we can get rid of the negative by doing that. And x to the a over b is written as the b root of x to the a. So we can combine these two for this one to rewrite it, and I get 24x cubed plus 1/3, but it'll be 1 over 3 times this, 1 over 3 times the cube root of x squared. So positive in this version, it would be looking like that. Second question was this one, y equals 2x plus 1x minus 3. Same logic as the previous one. We want them written as single terms all on their own. So in this case, what we have to do is multiply out the pair of brackets. Now, you know how to do this. Think back to National 5 when we learned the FOIL acronym. We work that through and do that here. So multiply them out and I get 2x squared minus 6x plus an x. So it's minus 5x, and then 1 times negative 3 gives me minus 3. So I've got them written out term by term. It's now a case of doing the derivative. Now remember, it's y equals, so we denote our derivative this time with dy by dx rather than f dashed of x. We then work it through. So the first term, write down the 2, bring the power down, I get 2x, and then my new power is 1. And then the second one here, it's minus 5 times x, and when we take the derivative of x, it's just 1. So it's then just minus 5, and the derivative of the negative 3 becomes 0, so we just drop it. We then sort these terms, so 2 times 2x gives me 4x. Now remember, if the power is 1, we don't need to worry about writing that, we can just leave it off. So we then end up with 4x minus 5. Writing out, doing the derivative one step at a time. Final question was f of x equals x cubed minus 2 over x squared. Now something like this, what you have to do is we still want it in that form. So we split this off into separate little fractions, simplify those, and then we work it through from there. So this one here, what I'd do is take each term on the top and split it into its own fraction with a denominator being the same. So in this case, I'd have x cubed over x squared take away 2 over x squared. Think back to our fraction operations. If we were to do this to simplify and combine it, we get back to the start. So we're just separating it all up. Simplify both of these. So I've got x cubed over x squared. Well, that just leaves me with x. And then I've got 2 over x squared. Well, that's simplified as much as I can in terms of the letters. It's now making sure it's written in that form of ax to the n. So we could take the derivative. So x squared comes up, and I get minus 2x to the negative 2. Then we take our derivative. We've got it written as we want. We can then calculate f dashed of x from there. So derivative of x, that's just 1. So then take away 2 times the derivative of this part. So again, power down in front, reduce it by 1. So it's negative 2x to the negative 3. Remember, negative 2 take away 1 is negative 3. Don't fall for that trick that you see quite often where they'll do negative 2 take away 1, but go back the way to get you to negative 1 rather than negative 3. So in a case of simplifying it, so I've got 1, and then take away 2 times minus 2 gives me plus 4 x to the negative 3. And again, we might look to write this with a positive index depending on the question. To do that, take it to the bottom, and I get 1 plus 4 over x cubed. And that's my answer for the final question. So remember for these, same general steps for each of them. Write them all out as each single individual term on their own. Always like this, even if the power is negative, in this sort of case here, we would bring it up from the bottom of a fraction, or the power itself is a fraction because we've simplified roots. Always write it like that, then you can just do each term one by one, and simplify it from there. Hope that went well. I'll see you in class.